Hello good people, I'm going to continue talking about naming of organic compounds. This time I'm going to throw in drawing of isomers into the mix. I'm also going to invite you to do something. Pause the video and draw and name the three structural isomers of C5H12. I suggest using skeletal formulas. To make things a little bit easier, here are the guidelines for naming of organic compounds. I will give you a few seconds to sort yourself out. One of the ways to begin this is by drawing a chain of carbons. How many? Well, in this case 5. Just to make it clear, I am also going to number these carbons. I have the correct number of carbons, but do I have the correct number of hydrogens? Carbons 1 and 5 have 3 hydrogens attached to them, and carbons 2, 3 and 4 have 2 hydrogens attached to them. So everything checks out. 3 plus 2 plus 2 plus 2 plus 3 is 12. What is the name of this compound? Well, I need to identify the longest continuous chain. And in this case, it is straightforward. It is these 5 carbons. I am only dealing with single carbon-carbon bonds, so this is now a pentane. To be really specific, I could say that this is normal pentane or N-pentane. Okay, that is one isomer done. I need 2 more. How do I go about determining the other 2? Generally speaking, a good strategy is to initially make the longest continuous carbon chain 1 carbon shorter. What do I do with the missing 5th carbon? I attach it anywhere else. So I'm going to attach it here and see what happens. I'm going to identify and name the longest continuous carbon chain. In this case, that would be these 4 carbons. And so this is a butane. What do I have outside of the main continuous carbon chain? I have this methyl group here at the top. I can say that I have a methylbutane. Where is the methyl located? To answer that, I need to number the carbons so that the groups end up with the lowest numbers. In this case, this means numbering from left to right. Now I can say that the methyl group is on carbon number 2. The name of this isomer is 2-methylbutane. We're almost there. One more left. I'm going to make the longest continuous carbon chain shorter yet again. Currently, I only have 4 carbons. I need to attach the last one. Where do I attach it? I'm trying to attach it somewhere so that I end up with a completely new compound. If I attach it here, it is still going to be 2-methylbutane. In essence, I have taken this compound on the left and flipped it around. If I reattach it over here, well, then it is definitely 2-methylbutane again. If I attach it up here at top, well, this is still 2-methylbutane. I just keep rotating it around. What is left? Well, I can attach another methyl group down here to this carbon in the middle. What is the longest continuous chain now? It would be these 3 carbons. And I have 2 methyl groups that are not part of the longest continuous chain. So far I could say that this is a propane, because I have 3 carbons in the longest continuous chain. I can say that I have methyl groups attached to it. More precisely, I have 2 methyl groups, so it is dimethylpropane. I also need to say where those 2 methyl groups are located with respect to the longest continuous chain. To that end, I need to number the longest continuous chain. I have 2 methyl groups on carbon number 2. So the name of this compound becomes 2,2-dimethylpropane. Now, as it turns out, these 2 isomers have common names as well. 2-methylbutane is sometimes referred to as isopentane, and 2,2-dimethylpropane is sometimes referred to as neopentane. So yes, organic compounds have their systematic IUPAC names, but some of them also have common names. And you have encountered that before. we tend to talk about water rather than dihydrogen monoxide. You can probably imagine that as the number of carbons increases, the number of isomers increases as well. And once we throw in double bonds and triple bonds into the mix, even more doors to even greater horrors open up for us. That is all for now, and I will see you on the flip side.